Hello everyone. We are team number 33, and the name of our project or our language is called LAKY. It's made using all our initials, basically LAKY, all the people who have developed this language, and we pronounce it as Lucky. I'll just quickly introduce our team to everyone. If you could just go on next slide, please. Yeah, thank you. My name is Aditya Mule. We have Lichi Hugh with us. We have Yunhan and we have Karan with us.
Right.
All right. So, yeah, you can just skip to the next slide now.
Okay, so let's get into the language description. So the first one, Lucky supports variable declarations with optional initial values for integers, strings, and booleans. It has basic arithmetic expressions using addition, subtraction, multiplication, and division. It also has Boolean expressions with relational operators, such as greater than, less than, equal to, and logic operators such as not, and or. It supports simple conditional statements with if and else. Also, it has ternary operator for conditional expressions. It supports while loops. Also, it supports for loops with two different syntaxes for Java and Python style. It supports basic input-output functionality through a print statement. Can get into the
Okay.
next slide. Okay, let's talk about syntax. So for assignment, we have the sample program here. So we can in x equal 5 and also the boolean y equal true. Also have string they equal. I hope you enjoy working with Lucky. So for ternary operator, we have the turn maybe condition and followed by the execute if true, and if the condition is true, we can execute if true. If condition is wrong, we do the execute if false. And for if else, basically the same logic as the ternary. We If the condition is true, uh ex we do then execute if true. If condition is wrong, we do execute if false. So for loop child type, we have for command, we have variable assignment, variable range, and followed by the expressions to execute, and for Java to end the for loop. For loop Python type, we have uh, the variable, we have for the variable name in range. We use the range start to give it the domain, and we use expression to execute to do the command. For the while loop, we we use a condition. If the condition is true, we do expressions to execute and use the end while to end the while loop. Okay.
So I'll take over from here this point. So this is basically the sequence in which the code is executed. So beginning from the application, from the UI, we first enter our code into the UI. Then that data is passed as arguments to the Flask backend. Here, to begin with, actually, we are using front end as Angular and backend as Flask to make this web application, and this is how we are showing our UI. And we are creating executables out of the prolog file, out of the PL file, and we are executing the queries from the executable. So these are, as you can see in the steps, first we enter the data in the front end, we enter the code, and then once we click on submit, it will be passed to the Flask backend where the executable is first created. So as of now, we have created laky.exe uh, executable file, and then into that executable, the tokens are passed. After that, the query is executed and the output is passed to the front end. So I'll just show a slight demo of it. So this is the front end of the LAKY UI application. This is the web application. And this is the terminal where I'm executing the Flask backend. So once I run this, the data is passed and the output is shown as well. I'll just show another program, just one small test case. So here the string is being printed. So this is the order in which our program is being executed. Right.
All right, so moving on to the grammar, we have updated our grammar quite a bit from the milestone one submission that we had made. And the grammar is pretty simple, to be honest. The program starts with a begin and ends with an end keywords, and we can make any number of declarations in between. And it's basically like variable declarations of different data types like int, string, or boolean. And once we have declared our variables, we can execute any kind of commands on it, which is basically everything a program can do, including conditional statements, like looping statements, or just regular assignment, or even just printing. So if Karan, please just move on to the pass tree generator directly now.
Right.
The next slide, yeah. So the pass tree generator is basically in the milestone one submission, we had mentioned that we are still confused if we should be using like Antler or Prolog, because even though Antler makes the work pretty easy compared to Prolog once we have the grammar implemented, but we didn't like none of us were actually familiar with Antler. So we tried our hand at it, but given like the really little time that we had, we did not feel confident enough to complete the entire project in just Antler. So that's why we decided to just stick with the Prolog, which we were already familiar with. The pass tree generator is created in the Prolog using the tree nodes. So if we could just switch to the next slide, please. Yeah. So if we take into consideration the sample program, which is a very simple program, it's we just have an int x which equals 10, and we have two other variables y and z. And y is again assigned to 0, and it's just a conditional statement. If x equals 100 and y equals 0, then z should be 5 or z should be 3. So if we go to the next slide, yeah, we see that once we run our program through the pass tree generator that we have in Prolog, we will get this intermediate code. Now, this intermediate code has all the tree nodes required as the tokens, which would be later fed as input to the evaluator. If we could go to the next slide, please. Yeah. And using the SVG tree option in Prolog, we have visualized this pass region, like the pass tree which is generated for the sample program shown before, and we can see that the program basically like starts with the program has a block which has declare and commands, and in declarations we declared x equal to 10, and we just declared y and z as it is. And in the commands, we first assign y to 0, and in the conditional we're basically checking if x equals 100 and if y equals 0, then it should be assigned to 5 or 3. And so this pass tree, which generates all the tokens when it is fed as in the intermediate code which we saw earlier, when it is fed as input to the evaluator, we get our correct output of the program. So I hand over to Liam, who will explain you how the evaluator works in Prolog.
So hi, I'm Liam, and so I'm just going to tell the evaluator. So our evaluator is written in SWI Prolog. So it will take the parser's intermediate code as input and evaluates it to actually execute all of the instructions. So in the following slides, we're going to show the output like product for the previous show sample program. So just go to the next slides, please. So here's the output, and I'm going to show how it runs. So just goes up previous slide, previous slide, and previous slide, and previous slide. Yeah, so for now, this simple program is pretty, as Aditya mentioned, is pretty simple. And so now we assign x equals 10 and y equals 0. So x doesn't equal 100 and y equals 0. So in that case, the program will allow you to go through the else, so z equals 3. So it will store z equals 3 in the program. Yeah, so just go to the output slide. Yeah, so it works like that. Yeah, and next one. Yeah, so that's how our program shows. So yeah, so as a open blanket, so you can just type your program, and it's like a same program. So after you click run button, and it will shows the output equals 3. And if it's success, it will shows program run successfully. So yeah, so that's how it works. And Karen is going to show how all the sample runs in our files, how it runs. So yeah, so Karen.
Yeah, thank you. I'll just show a few sample runs and explain as show the run. So we are picking our sample programs from our GitHub repository, which we have typed in the data folder. So I'll just paste it here and I'll run. So upon running the program, we directly get the output of wherever the print statement is. So since we are printing Z, we are able to see the output Z. Also, as of now, the UI is quite simple, and in most cases, you will need to add spaces here and there. Otherwise, there might be some issues. Also, normally, as of now, since this is the very first version, we are not able to display errors properly. So I'll just display a sample failed run. So this is the error as of now. So upon successfully running, it will indicate that the program has run successfully and it will show the appropriate output. So I'll just run all of the sample programs. There are 7 sample programs. This is the next one where we are just displaying a string, a pretty simple program. Now for the next one, here we are doing a couple of things. So we are declaring 2 variables, and if x is greater than y, and as of now it is not greater than y, so it will go to the else one. It will print y, otherwise it would have printed x. So here we are seeing the output 7, which is the value of y, right? So you go to the next one. So here we are simply iterating through the loop, and we are printing x while incrementing the value by 1. So we are making use of the for loop here, the Java for loop, and we are printing the value of x as it is being incremented. So in this program, we are making use of the do while loop, and we are printing the value of x as it is being incremented. And for the last one, okay, we are making use of the Python for, where we are incrementing the value of x by 3, and we are iterating it 3 times from 2 to 5. So these are the sample runs.
Could you also just show the sample run of the ternary program? I think we might have messed up.
All right. I think it was 5. Yeah. Yeah. Thanks for picking that, Aditya. Yeah. I'll just show this as well. So this is a simple program where we are just comparing the values of x and y, and based on that, z will either be true or false. So since x is greater than y, the value of z is being assigned to true, and we're just simply printing it after the ternary condition. So let's say if y was greater than x, so I'll just make this value 12 and run. So this value will be false. So this is it for the sample runs.
So as you've seen here, we have our entire programming language designed in Prolog, but we have implemented a UI in Angular and using the Flask for the backend. In doing so, we have created basically a really simple UI where we can just type in your program according to the correct syntax and hit run to get the correct output. But the actual program is completely implemented in Prolog. Thank you so much for listening to our presentation, and we hope you have a good day.
Thank
Yeah,
you.
thank you, everyone.